So this is the function that I have for that question number. And you need to take a first derivative and a second derivative in order for you to use the second derivative test to find the relative max or min of the function. So the first thing you want to do is do the power rule. So you're going to pull the power down in front and then decrease it by 1. And then you've got the inside to take the derivative of. So this is going to be the chain rule. So, I mean, this is like u squared, and then take the derivative of that. So it's going to be 2u to the 1, but then you've got to take the derivative of what's inside. So I'm taking the derivative of this using the chain or the quotient rule. So the quotient rule says bottom times the derivative of the top, which is 1, minus the top times the derivative of the bottom. So again, derivative of 1x is 1, derivative of 1 is 0, all divided by the bottom squared. So take x plus 1, the quantity squared. From here it becomes a lot of algebra. So I still have the 2, I still have that first fraction, x plus 1, and then here I just distributed the 1 and kept the denominator. And then from here, these x's, x minus x, cancels out. So I'm just going to multiply straight across. 2 times x times 1 is 2x. X plus 1 times x plus 1 squared. So that's like taking one of these and two of these and getting a total of all three of them. So this is your derivative of f of x. So now you need the second derivative. So you go back through the process again. Bottom times the derivative of the top minus the top times the derivative of the bottom. So you bring down the 3 times x plus 1 quantity squared, and then the derivative of the inside. So the derivative of 1x is just 1. All divided by the bottom squared. Well, the bottom was to the third power, so when you square it, anytime you take something and then square it, you multiply the powers together. So it's going to be u to the 6th power. When you raise a power to a power, you multiply. From here, I noticed a couple of things. I don't want to multiply this whole thing out. So I see that I have an x plus 1 and an x plus 1 factor, and I have a 2 and a 2. So I'm going to factor out the 2, and then the x plus 1, I have 3 of them here, I have 2 of them here, so I can at most factor out x plus 1 squared. And then I have what's left over. So I took out a 2 from the first one and an x plus 1 to the 2 power, so that left me with an x plus 1 to the 1 power for the first term. If I took out the 2 and the x plus 1 squared, that left me with a 3 and an x with a negative in front. So the next thing I did was multiply x time, or not multiply, but add a positive x and a negative 3x is negative 2x plus 1. And then I had the 2 out in front here. Alright, so what happened to the x plus 1 squared? Well, you have 2 of them on top, but you've got 6 of them on the bottom. So when you cancel, you end up with 4 of them on the bottom. Alright, so then this can become negative 4x plus 2 divided by x plus 1 to the 4th. Alright, now that you have your first derivative and your second derivative, you can find out where the first derivative is equal to 0 by setting the numerator equal to 0. Solve for x. And then I think you plug that value into your second derivative to determine the sign. If it's positive, it's concave up, which means you had a relative minimum. And if you plug the point in and it becomes a negative fraction, then it's concave down and you had a relative max as your point. All right, so I hope that helps. That's kind of that's probably one of the bigger questions in that section.